Hello everyone. Today we'll be talking about the vector data type in R. As I mentioned in my last video, we don't type numbers manually into R like a calculator. We store them in objects and we use those objects in our later code. One of the types of objects in R is called a vector, and vectors are for one-dimensional data. So for example, if I have the numbers 1 to 100, and here's a little trick in R, if you want a sequential set of numbers, you can just do your first number colon your last number, and that will tell R that you want a vector with those numbers in order. So here we have a vector of the numbers 1 to 100. And let's store this in an object called myVector, which will itself be a vector, of course. So we've created our vector. It has 100 values in it. What can we do with that data? Well, one of the first things we can do with it is simple math. So if I take my vector, I can add 1 to each of the values in that vector by doing this. So R knows that if you have 100 numbers and you want to add 1, it's going to add 1 to each of the 100 numbers, as you can see down here in the console. Okay, what happens if I want to add different numbers to each of the numbers in my vector? So let's say I make a new vector. We'll call it my other vector. And this will be the numbers 101 to 200. So notice that it is the same length. Both of my vectors are the same length. They both have 100 numbers in them, which is important when doing math like this. So my vector plus my other vector, because they're the same length, I can simply add them together, and you will see that what you get is the first number of the first vector. Remember, the first number of the first vector was 1. And the first number of the second vector here, I'll make this explicit, I suppose, is 101. So 1 plus 101 equals 102. The final number is 300. That's the 100 from the first vector plus the 200 from the second vector. So it just paired them all up and added them pair by pair. What happens, though, if you try to add together vectors that are of different lengths? So let's make some small vectors. To do this, I'm going to showcase the first function that we're going to learn in R. So R is often built around using functions. And what a function is, it's a bit of code that takes an input and produces an output. So the function we're going to use is C. So if you type $C into the console, that will pull up the help document over here in the bottom right. And you'll see that it is a function to combine values into a vector or list. So we're using a vector at the moment. So let's say my small vector wants the numbers 1, 5, and 6 in it. Okay, so we're going to make this vector again using just our arrow notation or an equal sign. And now we're going to use the function. And to use a function, you do the name of the function and then a set of parentheses. And inside this parentheses is where you will put the inputs for the function. And it will produce outputs that are then saved into whatever object you have created over here. So we want the numbers 1, 5, and 6. So I'm just going to put those numbers in separated by a comma. So that's going to put the numbers 1, 5, and 6 into the C function, and it will produce a vector with the numbers 1, 5, and 6 in it, called my small vector. And then let's do my larger vector. And this one's going to have the numbers 1, 4, 6, 4, 8, 4, whatever. So now I have two vectors of uneven length. It just so happens that one is exactly twice as long as the other. So let's see what happens when we do math with this. So my small vector plus my larger vector. And you'll see that it didn't produce an error, even though the vectors are different lengths. What it did is it recycled the shorter vector twice so that it had enough numbers to work with the smaller vector, or the larger vector, excuse me. So this 2 is coming from 1 plus 1. This 9 is coming from 5 plus 4. This 12 is coming from 6 plus 6. And then this 5 is now coming from 4 plus 1. It's looped back around to the beginning of the small vector. What if they weren't multiples of each other? Let's say we had, I guess let's leave this one and let's just add a number here, 7. Now we get a warning. R says, oh wait, these vectors are not a multiple of each other in length. Are you sure you want to be adding them together? That said, it's still produced an output. And it's still doing the same thing where it's looping back the exact same way it was doing when they were a multiple of each other. So we get 2, 9, 12, 5, 13, 10, and then this 8 is just this 7 here being added to this 1 because it's looped back around, but it's only getting to the first number before it runs out of numbers here, so it doesn't finish recycling the smaller vector. So I hope that makes sense. So essentially what I'm trying to say is you can add vectors of uneven length, and this is how R handles that. Just something to be aware of, because often you don't really want to be doing anything with vectors of uneven length, but R will do that, so just be aware of it. Okay, let's talk about another important thing that you do with vectors, which is pull out a subset of values from it. So let's say we want all values less than 5 from my larger vector. Okay, so to pull out a number from a vector, you do the name of that vector, and then you use a square bracket, and you do an index of the position of the number you want. So let's say I want this first number here for my larger vector. If I do square bracket 1, because this is the first position, that will give me a 1 in my output. What if I want this 4? Well, that's square bracket 2, because that's the second position. And it's important to note here, if you have any experience coding in other languages where maybe you're used to a 0 being the first index in your object, R is just different. R uses a 1 as the first index and then counts from there, whereas other languages might count starting from 0. So just note that that might be different from what you're used to. If you don't have any coding experience, this probably makes way more sense to you than using 0. Either way, know that this is how it works in R. So this allows us to pull out a single value, but that's not particularly useful. We want all of the values less than 5. So what we can do is use an index by creating another vector in here that has all of the values that we want out of the myLarger vector. So we want the first value because it's less than 5. We want the second value because it's less than 5. We don't want the third value because 6 is greater than 5, but we do want the fourth value. We don't want 5. We do want 6. We don't want the last one. So if I do this, we'll see we got the numbers 1, 4, 4, 4, because we got the first, second, fourth, and sixth values out of myLarger vector. Hopefully that makes sense. There is another way to do it, though, because obviously this wouldn't be particularly useful having to type out the index of every number you want, especially when you get to larger vectors. So another way you can do this is with a logic vector. So I'm going to do this explicitly at first, which is not how you do it normally. It obviously would be too tedious. But I'll show you later why I'm explaining it this way. So a logic vector means you create a vector, but instead of doing the numeric positions of the values you want, you put in a logic value for whether or not you want each position. So we do want the first position, so all capital letters true. We don't want the second position, so all capital letters false. Sorry, actually we do want the second position. We don't want the third position, so that's a false. We do want the fourth. We don't want the fifth. And you'll notice if I put a space here, it doesn't actually matter. So white ignores white space pretty much. I tend not to use it sometimes, and sometimes I use it, but I try to keep it consistent within each chunk of code. So, okay, I digress. We do want the first position true, true, false, true, false, true, false is what we want at the end of this. So now we have the same output. We have 1, 4, 4, 4 because we retrieved the number from all of the positions where we had true here, and we did not retrieve the numbers from all the positions we had false. Okay, so why would you use a logic vector? This seems pretty tedious. Well, the reason is there are much easier ways to make logic vectors by doing logical comparison. So if I take my large vector and I use the less than symbol 5, what that does is it loops through each number in my larger vector, and it looks at that number and says, is it less than 5? So in this case, it's going true, true, false, true, false, true, false, which is what we did here, which means the simplest way to get each number less than 5 out of my larger vector is to do the name of the vector, square brackets for an index, and then to do this comparison, my larger vector less than 5, which is creating a logic vector inside the index, and that now pulls out all of the numbers less than 5. Okay, that's great. What if, we now know how to index vectors, we know how to create them. What if we want to add two vectors together? So what if we want to add, let's just add the big vectors. Let's add my vector and my other vector together. And just a reminder, that's the vector of 1 to 100 and 101 to 200. So take a second, think about what might we do based on the function that we already know. Hopefully what's coming to mind for you is that you can take the C function and input other vectors into it. So now C, again, it's a function, so I'm going to use parentheses to just denote what inputs I want for that vector. And I can do my vector and my other vector. And now we have a new vector of the values 1 to 200. Okay, so just to recap for vectors, they hold one-dimensional data. You can do simple math with them. You can index them using numbers or logic vectors. And you can create logic vectors with comparators. So you can do less than, you could do less than and equal, which is written like this. So if I wanted all the values less than or equal to 5, I just do the less than or equal. In this case, it doesn't matter because there is no 5. And you can add vectors together using the C function. One other thing to note is that vectors have different types. So far, everything I've been showing you is a numeric vector. It's a vector of numbers. That allows you to do math. You can also make character vectors. So let's just make a character vector. And what's different here than doing it with numbers is you put characters in quotes. So you can do A, B, C, and that will create a character vector with 3 values, and you'll notice it's denoted as a character in our little environment window here. If you try to do this without the brackets, R is going to throw an error, and the reason it's throwing an error is when you have text with no bracket, it thinks you're looking for an object. So just like up here where we did see my vector or my other vector, R thinks there's probably an object called A, B, and C that it should find, and it can't find it. So R needs those quotes to tell it that you are indeed adding text. And it can be any text you want, even numbers, like 1, 2. And that will all be stored as a text format. And that's important to know because you could have a vector of numbers as characters where you do something like this. And this actually happens pretty frequently when you import data. If that data type is not detected correctly when you're importing it, you'll end up with a column or a vector, column in a spreadsheet, or a vector that's numbers, but it's being stored as text. So you'll end up with a vector like this. It's a vector full of numbers, but here you can see that R is treating it like a vector full of characters, and you cannot do math with this. So if I do numbers as characters plus 1, R says, oh, a non-numeric argument to a binary operator. It thinks you're trying to do math with text. So how do you get around this? You can convert text to numbers using as.numeric function. So again, if you ever need help understanding what a function does, type question mark and then the name of that function, and that will bring up the help file over here. And you'll see that as.numeric creates or coerces an object of type numeric. So the way we're going to do this is as.numeric, and that will run just fine. And of course, if you wanted to convert the vector entirely, you can just run the as.numeric function around your vector and then save it back into the vector, so effectively replacing the character version of the vector with a numeric version of the vector. And you'll see over here, if we run that, we get that is now a number. You can do math with it, etc. Okay, so that's all you'll need to know to get started with vectors. Next time we will talk about matrices, which is storing data in 2 dimensions.